this again. So the diagram is given, right? And this is 100. These are 100 centimeters. And there's a 400 Newton force pulling downwards, right?
Yes.
Okay, so then there's tension in, what are they, strings? Tension in the strings, right? So to figure out the tension in the strings, we first need, just like we did in that last example, we need the angles.
Oh, so use cosine.
Yeah, use the cosine law. So the cosine of theta. Now again, I use theta for both of them because it's an isosceles triangle. It's going to be the same angle. Once we find one, we have the other. So the angles, the sides between the unknown angle, 120 squared plus 100 squared minus the one across from it,
Okay.
over 2 times 120 times 100. Okay, so then the cosine equals 120 squared is 14 over 2 times 120 times 100, which is 24,000. Shift cosine bracket 14 divided by 24,000. The angle works out to be 53.1. So that's up here is 53.1 and 53.1, right? Mm-hmm. Okay, so now we're going to draw the vector diagram. That's why I like the other program, because I can make the page go down and still see this. But this one I can't, obviously. Oh, what happened? I can't go back to the other slide? Oh, I did. Okay, so that was 53 up there, right? And that was 53? So now we'll draw the vector, because that was the position diagram. That's how it actually looked, right? So now the vector diagram. We had that, which is the one string, right?
Which is 100, right?
Yeah, it's 100 centimeters long, right? And then the other string, which a vector that I moved to the top, right? The tension, right? Like
So
I did.
it's still 100, right?
Right.
Still the same.
100 centimeters. And then that's just the length, right? And then, but we know that the force keeping the state of equilibrium is 400 newtons, right? So if I draw on the horizontal here, we just figured out that this angle here was 53, right?
Off the horizontal, right?
Yeah.
So 53. So if you,
Right. So both of these are 53. So then 53 plus 53,
it's actually 53.1.
53.1. So that'd be 106.2, right? So remember that these angles here and these angles down here always add to 90, right? So this one here and this one are going to add to 90. So 90 minus 53.1, this is going to be 36.9.
And then that's the same for the other side.
Right. So now really all you have to do is figure out the tension in one of them, because it's going to have the same tension, right? Hold on. So the tension over the angle across from it, which is the sine of 36.9, is equal to 400 over the sine of 106.2, right? Isolating T1, it's 400 the sine of 36.9 divided by the sine of 106.2. So that would be 400 sine 36.9 divided by sine 106.2. That would be the tension in the wire is 250 newtons. So that tells me since the tension is below the 300 newtons, the string's not going to break. Okay? If it worked out to be 350 newtons, then the string would break. Okay? So now in part B, I'll just kind of set it up for you, then you can try it, right? So what it's saying is, will the string break if the weight is 80 centimeters from one end of the string, right? So this was 120, right? Now it's 80 centimeters.
So you do the same thing.
Right, the exact same thing, but now you're going to have to find these angles. This time these angles are going to be different.
Why is that still 120? Oh, because they still have to equal.
200, right? Because it's you have a 200 centimeter length string. It said so in the question,
Oh.
right?
So then instead of it being 100, 100.
Right. So now, but now it's being pulled down here. So you're gonna do the exact same thing we did. So use the cosine law to figure out this angle. Use the cosine law to figure out that angle. Draw your vector diagram, right? And figure out the tension of both wires. And if the answers are above 300, they're gonna break. If it's not, it's not.
Okay.
Okay, is that good?
Yep.
Okay, so stop
Thank you.
this.